researchers, students, and participants who have joined us today from different places. About organization, International House of Education is committed to promoting academic excellence, interdisciplinary research, and knowledge sharing through conference, webinar, and educational initiatives as national and international levels. We are delighted to host today's insightful online webinars on the topic data analytics using Excel. The objective of today's webinar is to provide participants with the meaningful insights into emerging trends, practical applications, and the growing relevance of this subject in today's rapidly evolving world. It is now my privilege to introduce our esteemed speaker for today's session, Dr. Santhosh N, distinguished academician and researcher in mechanical and aeronautical engineering specializing in composite material manufacturing process and infant element analysis. Currently serving as head of Department of Mechanical Engineering at Dayananda Sagar Academy of Technology Management. Sir has published over 90 research papers in Scopus and Web of Science indexed journals, authorized more than 15 books, chapters, and presented more than 50 papers and research articles at international conference. Sir research focus on advanced materials, frictions, stir, welding, turbology, and aerospace applications. Dr. Santhosh has filed multiple patents in areas such as composite materials, IoT-enabled tracking devices, and automation robotic system. Sir has successfully led funded research projects including grants from DST, TechUp, World Bank, and ISC with a total funding of over rupees 18 lakhs. His project over topics like energy harvesting, hybrid metal, matrix composites, and rapid compositing machines. As a chairman of the board of studies, board of examiners at various autonomous colleges and deemed to be universities. He oversees academic policies, examination, reforms, and the assessment procedures. He has been instrumental in NBA third cycle and NAC second cycle accreditations, ensuring academic excellence. He also serves as a IQ, a member NRIF coordinators, and the convener of the results and the granting advisory committee, handling CGPA or SGPA calculations and academic integrity measures. Dr. Santhosh has established state of the art laboratories at various institutions, including a metro mechatronics lab at Crest University and flexible manufacturing and advanced material categorization labs at MVJCE with IoT metal characterization and prototyping facilities as a visiting scientist at SUT University, Thailand, along with Dr. Ashwin Seagoud as Special Officer VTU. He has contributed to international collaboration in advanced materials research. Recognized, Santosh sir has recognized for his contribution. He has served Best Paper Award, Fundry Man of the Year Award, and letters of appreciation for research excellence. With his blend of academic leadership, research, innovation, and industry collaboration, he continues to make a significant impact on engineering, education, and applied research. Thank you, sir. Over to you, sir.
Thank you, madam. Madam, can you kindly give the sharing option, madam? Sharing option.
Okay, sir. Admin,
Uh, I don't want inside.
admin,
Yes.
kindly provide the sharing option to sir.
Yes. Is it is it visible? Is the screen visible to you?
Yes, sir. Yes, sir. It's visible, sir.
Okay. Thank you very much, madam. Thank you for your wonderful introduction, as well as I am very much grateful for IHE for providing me this opportunity, especially to share my inputs related to the data analytics using Excel sheet. Because we all know in the current day trend, data analytics has become one of the major aspect, particularly related to any of this experimental work, as well as theoretical formulations or anything for that matter, even from basic research activities to the day-to-day expenses, other things, we can use the Excel. It is a basic tool which we can use for number of applications. So basically, what is the purpose of this presentation is, I would like to give how this data analytics, all the basic functions in Excel we all know, but majorly we want to know how this data analytics particularly related to one of the key aspects, especially when we consider for experimental studies, how to improve the decision making, how to identify the trends and patterns, how to solve or predict the values, particularly coming to this scope of mechanical research, which I will show as a case study, how to predict the future outcomes. Say I am carrying out experimentations for three composition, say 10%, 20%, 30%. Suppose I don't know what will happen to my hardness value or wear rate or say particular impact resistance or flexural strength, then I can predict it using the basic Excel tool itself. I need not have Minitab software or design expert. Using this only, we have some of this descriptive analytics method, predictive analytics method, using which we can do the basic data analysis using the Excel sheet. So, coming to this learning objective of the session. So, by end of this session, the participants will be able to define key concepts of data analysis, use the data analysis terminology, and select the appropriate chart. Which chart to select, whether bar chart, pie chart, trend chart, or line chart, like that. They will be able to understand which chart to use for their data. So in that way, some simple tools, basic analysis and reporting using Excel that we are going to see in this particular session, which can be handy, especially for all the research scholars, UG students and PG students. This will be very much handy when they are plotting the graphs, especially for their experimental values, as well as when they are analyzing the results. For all these things, this will be very much handy for them when they are doing basic experimental trials. And also, this can be used in our day-to-day basic analysis of expenditure pattern, even housewives and even people who are accustomed to using the manual ledger for accounting, keeping, they can collect the data where they can perform simple calculations, summarize the results, and present information in simple, easy to understand format using the Excel sheets. So in that way, it is very much helpful. Excel is very much helpful for almost everyone. So because this is everyone, we will have Microsoft Office tool in our system. Any person who purchases the laptop or desktop, we will be having basic tools or basic components in his system. So basic sum, average, count, maximum, minimum, logic operations, sorting, filtering, that anyone can do it. So basically, what is this topics that we are going to consider is here we are going to understand about certain basic descriptive analysis like ratio, proportion, percentage, rate, median, mean, and trend, and selection of the appropriate chart in the Microsoft Excel tool, like which chart will be better and which are the key aspects in this. Which bar chart can we take, or can we take any of this line chart or pie chart or column chart, that we can do it. So basic operations today we will do using the Excel sheet, and we will try to understand how each of these components are very vital when we are discussing about this Excel data analysis using the Excel. So, what is this data analysis? Whenever we discuss about data analysis, it is all about turning the raw data into useful information. For example, say you are going to use quite a lot of data you are going to get when you are doing a survey or when you are doing their every minute experimentations or for example if you take a health program you have done survey chart, that is you are from a management background or you are doing any other courses wherein lot of samples you are collecting. So greatest amount of data will be there, even best quality of data you may have, but if it is not properly analyzed at all, then what is the use of the data? So for that, we require what is known as data analysis. So data analysis means not only you should know Python, you should know IBM SPSS tool or Power BI tools for visualization or Microsoft Visual Basics. Some simple things you can do using Excel file itself. Like you can remove the duplicates in the data file, you can handle the missing data, or you can convert text to columns, trim the things. Okay, like that, you can do the sorting using simple data. So, what is that requirements which we basically do in the data analytics in Excel is we are going to analyze and we are going to compare how program targets and actual program performance are going to converge and how far we can learn from the targets and why we have achieved that or not. We can get the information through this Excel. That is basically what we do is we all know about basic statistical terms like a ratio, proportion, percentage, rate, mean, median. Okay, so all these things, how much is the percentage increase or percentage decrease? All these things we can get an information about using the basic data. So this one, I will just show you using some of the experimental test results which we are having, especially from one of our tensile flexural and impact test results which are having. This one I will try to make it more interactive by showing real-time results of our experiments. So all of you know basics of the Excel and you have already worked with the Excel, but when using with our experimental data, especially if you are working on any of these basic testing in case of the composite materials, or we are going to carry out some of the experimentations in case of the biofuels, or for example, you are doing any of the test results, or you are collecting samples. Say for MBA researches related to marketing, you are collecting quite a lot of samples. In that things, in such situations, some basic analysis which we can do using the data that I will be sharing now. I will just open my data set. Can you kindly, admin, can you kindly help me whether that data sets are visible to you? Is it visible, admin? Ah, yes, thank you.
Visible, sir.
So, okay, okay, thank you very much. So now, what are the basic data sets which I am now using it as a case study is here you can see this is one of the test data of the hybrid polymer composites which we have synthesized and we have got this test data that is ultimate tensile strength, elongation percentage. We have Young's modulus, flexural strength, flexural modulus, flexural deflection, impact energy that has been absorbed. So all this data for different trials, we are having trial 1, trial 2, trial 3. So this data we have considered in this experiment, L9 experiment, orthogonal array. L9 means We have three composition of this Moringa oleifera. So Moringa oleifera means it is nothing but drumstick, uh, nugekai, what we colloquially tell in Kannada. So it is a drumstick. So we have used this drumstick fiber. We have extracted it and we have hybridized it with glass fiber. So we have a Moringa oleifera in three different compositions: 10, 20, 30. And glass fibers we have restricted up to 0, 10, 20. So we are having a 3 cross 3, 9 combinations. That is 10% moringa alifera and 0% glass fiber, 20% moringa alifera and 0% glass fiber, 30, 0, and 10, 10, 10, 20, 20, 10, 30, 10, and again 10, 20, 30, 20, 20, 20. So it will make up to L9. That is, we are having a L9 orthogonal array. So we have done three trials on the because one trial we cannot get the accurate readings. Generally, in experiments, we carry out three trials or basically five trials based on the predictions or accuracy which you require. You can carry about three trials or five trials and take average of the reading, because sometimes the testing equipment which you are testing, the precision and readability also matters, because sometimes the reading which you get in trial one, you may not get in trial two and trial three, because precision is very important. Because always we tell measuring equipments precision with accuracy. Okay, so we all know accuracy is the degree of closeness with which we are going to approach the readings. But however, precision is very, very vital whenever we are discussing about the instruments, because we need to repeatably get the same reading. So precision makes an important role whenever we are working on this measuring equipments or testing devices. So that's why we always tell measuring devices are very, very important. So in this case, we have got the three trials readings for each of these things. So here, what is very important is any values. Very, very important is average, variance, and standard deviation. So before finding the average, variance, and standard deviation, let me tell why this average, variance, and standard deviation is very important for experimental purpose. What does this average tell, variance tell, and standard deviation tell? Basics of statistics is average, standard variance, and standard deviation. Why this average is very important means it is nothing but we all know sum by number of values, sum of the values by a number of the values. So why this average is, it will give the central value of the data. Central value means the mean value of the data it will give, and this variance will give how far the data are spread from the average, means values how far it is close to the mean, and low variance means it is very close to the mean. High variance value, if you get, values are widely spread from the central values. Okay, so that is very, very important. And standard deviation gives the square root of the variance, means average distance of each value from the mean, and it is basically, it helps us to give the central value. Where average means it gives the central value of the data, variance means it gives the spread of the data, and standard deviation means data dispersion, means how it data is dispersed. So these three things will help you understand the experiment whether you have carried out is correct or not. Okay, so variance itself, it will give you an understanding. Okay, if variance is less means we can understand that the experimental trials, it has some precision and repeatability, and standard deviation further confirms that. That is, the data dispersion is all along the central tendency or central line, and we can confirm this experiment and go ahead. So this is very, very important whenever we are discussing about taking the readings in an experiment and proving the average variance and standard deviation. So in this, you can see now I will do the average of the is equal to, we all know that function. Okay. So here in our Excel, very important is in the cell, if you once you type is equal to, you will open a function, range of functions. You have quite a lot of functions like mathematical functions, logical functions. You have different types of functions in the Excel sheets. So once you open the is equal to in the cell, you will get the functions in the Excel. Why this functions is important means it will give you uh, which operation you need to perform in the Excel, whether you are predicting the formulas or you are doing basic mathematical function like average, minimum, maximum, absolute value, or statistical functions like count the numeric cells or count based on the conditions, variance, or logical functions, if, and, or not, or text functions, left, right, or date functions. You have date functions, you can also create a date function like it should create a date, like you can just type today. If I type today, okay. So what is the today's date? It will give the date with reference to your value, and you can see the different results in this value. That is, it will create a date. This year, this month, or this day, like that. It will create the date, and you can also use VLOOKUP, vertical lookup, horizontal lookup, and advanced lookup in the functions, and you can also calculate future value, present value. In case of business loss, you can calculate future value, present value, loan payments, net present value. All these things you can calculate. Now I will use this. Now I want the average of this. So I will use this, select the three numbers and close it. See, I will just drag it. Yes, I got the average value of all this. Okay, average value of the different trials. So I've got, you can see which is the maximum and minimum. That also I can find out. Max. Okay. See, so here the maximum value is for 73.5, and it is for, you can see, M20 G10. And once again, I will go for minimum. Yes, 63.4, and this is for M10 G20. So you can clearly see the difference between the minimum and maximum. Okay, so why this minimum and maximum I have found out means, while writing the paper, research article, the editor will ask which was the minimum ultimate tensile strength you got, and which is the maximum ultimate tensile strength you got, and what is the percentage increase or decrease with reference to the base specimen or base epoxy composite, or how much percentage increase as there's this M20 G10 over M10 G20. So in that way, to find out that you can have this percentage increase or decrease in the value. So I can clearly find out what is the percentage increase or decrease between these two values. Okay, and I can identify how much percentage it has raised. Okay, 63.4, you can see. Okay, into 100. If I just make this, okay, into, so almost 15.9. See, here it has got rounded off. You can increase the values. Yes. So 15.9 percentage improvement as compared to the M10 G20. So this is you can use these values. Okay, you can use these values while writing the paper. For what it is maximum, you can clearly write it is maximum for M20 G10 and it is minimum for M10 G20, and when compared with M10 G20, the percentage improvement, okay, the percentage improvement is 15.9%. So this one you can uh, write in your abstract of the paper. Okay, abstract of the paper should comprise of what is the percentage improvement. In conclusion part also you can write. So now coming to variance, whether the experiment which we have carried out, it is correctly done or not, whether variance is high or less. So we will do for not for population but for sample. Population means entire this value but we want for sample. So we will go to variation, variance for sample, select it, select these three. Yes. So what is the variance? 1.2. So clearly we can make out the experiment is whatever we have conducted is almost we are getting values with precision. Why? Because variance is hardly between 1.2 to 1, that is at the minimum it is 0.4 and at the max it is 1.2. So clearly we can make out between zero point 0.4 to 1.2 the variation is there and it is admissible because if I do 1.2 by 68.9 it will be less than 5%, hardly 2.3% variation is coming between each of the experimental trials and we can say that experiment is almost the readings obtained in your equipment is almost right and you are getting the correct readings in your value that is in your equipment. So standard deviation also I'll go for standard deviation and I will get the standard deviation. Why all this variance standard deviation required means you are plotting error graph, bar chart. When you are plotting bar chart, they will ask, give the error bar for the bar chart. The error bar will be either plus or minus 5% or it will be standard deviation. Any of these things will be the error bar. So, for plotting the error bar in case of the set of experimental trials, we need what is known as the standard deviation. So that's why in this standard deviation is very vital. Now, similarly, we can do it for all the other readings. This. Now, very important is, I was mentioning in your Excel sheet itself, you will have quite a lot of operations. Like we all know in statistics, whenever we are doing experimental statistics and experimental values, we do very, very important thing, what is known as ANOVA, analysis of variance. What is this analysis of variance means? It is a statistical method used to compare the means of two or more groups. Here, two are this is one group, this is one group, this is one group. Or if you consider two or more groups, means of two or more groups to determine whether there are significant differences between them. So in this, there are different types of ANOVA, one-way ANOVA, two-way ANOVA. Okay, so it will give a very important thing F ratio. F ratio means it is nothing but variation between the group and within the group, and it will give especially single factor and multiple factor. It will give the statistics and probability of result by chance. Means what it will tell is, say suppose I have done two hypotheses. What this hypothesis means, any experiment, before doing experiment, I have to have some hypothesis that this from this experiment I will come to know that the tensile strength of this polymer or this composite is higher or I will make alternate hypothesis that the tensile strength of this composite as compared to neat epoxy is lower. Like that, I will make the I will build a hypothesis. Now, F value will tell whether the hypothesis you have built is correct or not. Whether you have to reject the hypothesis or accept the hypothesis. So how it will you will come to know whether you have to reject the hypothesis or whether you have to accept the hypothesis. That one I am going to now show. Now, very important thing in your Excel, you can see data. In data, very important, you can see data analysis. So all other functions, most of you have used in Excel, you have used all the analysis, data validation, everything you have done already in your basic day-to-day life. But very important thing which you have Excel and most of you have not used is data. So in data analysis, you can see you have quite a lot of data analysis tools. See, I can do ANOVA, single factor, two factor, correlation, covariance, descriptive statistics, exponential smoothing, F-test, Fourier analysis, histogram, moving average, random number generation, rank and percentile, regression, sampling. Here I can do quite a lot of aspects in this analysis too. Okay, so basic regression we can do. In this, very important, what I can do is basic regression. Say, what is that is, I want to predict for 10%, what is the value, for 20%, what is the value, for 30%, I came to know. Suppose I want to find out the value for 35%. So 35% means I need the equation, right? So for that you can do the basic regression. You can see input y and x. So what is the y value? Y value is our average. Okay. And x value, let me take moringa fiber. Okay, sorry. Y value, I will choose the range. Select y value, I'll choose the average. Next, X value, I'll choose the weight percentage of Moringa oleifera. Okay. And you can see confidence level. Okay. If you want, you can do the residuals. You can get all these things, normal probability plots. Okay. Click OK. Yes. You get this here. Normal probability plot you got. X variable residual plot you got. And you got the variable one residual part. Okay, how the residuals are varying and what y value, how it is varying, predicted y value, actual y value. You will get the difference between predicted y value and actual y value, and see here it will give the estimate regression r square value. Okay, see here prediction. There observed value. What was the observation that we have got? 68.9, whereas from the predicted Y result, it is 68.98547. Okay. Next, similarly, you can see uh, for M20G0, that is for 20% Moringa oleifera, we got 71.1 through experiment. Through the prediction, we are getting 68.50074. Okay. So you can, like this, you can get the multiple observations possible through this regression analysis. This is the basic fundamental of the statistical analysis which you can do using your Excel sheet. See here, you are getting the F value, you are getting the residuals, you are getting the sum of squares, mean squares, you are getting the p value, okay, and you are getting the predicted value, residuals and standard residuals, okay, and you are getting the probability output as well. Say a normal probability plot, you are getting the variable and residual plot. Also you can get the equation. Okay, so I will go to scatter plot. Okay, I will choose this. I will first choose this, and I will choose this. I will go to insert. Okay, I will go to the chart. Yes, I can. I will change this data format axis. Select data. Select data. Yes. Horizontal. So X value, series name, I'll make Moringa versus UTS. I'll choose this Moringa versus UTS. Yes. And Y value, I'll choose here. Select the data. Yes. Add series name Moringa versus UTS. X value, choose it. Yes. Next, Y value, choose it. Yes. So now you can click OK, and here you can have the error bars added. Okay, you can add the access status, data label. You can have the error bars and the trend line. Okay, in this trend line, you can give whichever you want, exponential. Okay, in this you can give the whichever trend line, whether you want exponential, linear forecast, more options you can go, and you can give the options, and you can get the equation also, linear, if you want linear, exponential, or more, you can go to, yes, exponential, and also you can have the legend shown over here, and you can predict the values with reference to different trend lines. Okay, and you can be able to, for different x and y, you can get the moving average as well. So now, why I told this, because when we are considering this basic regression statistics, you can clearly understand that one of the key features in case of this regression statistics is we are finding out R square value. What is this R square value in this is, R square value basically refers to your regression statistic value, particularly when we are discussing about curve fitting or prediction. Very important is R square. It is nothing but known as coefficient of determination. Means it shows how well the independent variable explains the variation in a dependent variable. So it is between 0 to 1, or sometimes it is shown as percentage. Okay, so if it is above zero point 0.9, it is a good prediction model. Means because 90% of the variation will be explained by the model. But here we are getting the different R square value. Why? Basically, this one we are carrying with not linear values but repeated values. This why we call it as L9 orthogonal array. Why repeated means here 10, 20, 30, 40, 50. That like that way we are not continuing. We are continuing like 10, 20, 30. Once again 10, 20, 30. Once again 10, 20, 30. Repeated values, repeated pattern of this value. So for each of this percentage, we are having three different trials. So here it is a we call it as design of experiment, DOE. So since it is DOE, here we can do the predictions, particularly with reference to rank of the values, which is having more effect and which is having less effect. In that way, we can do the prediction. Okay. So what we do is in this, basically, we carry about the prediction for different types of the values, particularly with reference to weight percentage of the glass fibers and weight percentage of the moringa fibers, and how much is the UTS value. For this, we are carrying out the analysis of the variance values. That is, analysis of variance means we are going to find out how the variance between each of these values in the given set of experimental trials is going to be predicted. So in that way, what it will help us understand is it will help us understand how the experimental readings which we have got, whether it is justified, and whether the variance standard deviation among each of the trials, whether it is getting as per the experiments which we are carrying out, whether it is satisfying the design of experiments which we have done, and how uh, well we can suffice our experimental results with the statistical values. Okay, this one it will help us understand. Okay, for that only we are doing the very important thing in our basic statistical analysis of this. That is, we are doing very important known as the ANOVA, analysis of variance. Now, let me do the analysis of variance and explain what is that analysis of variance is all about, and how we are representing this analysis of variance, and what it gives us, especially the ANOVA in using Excel sheet. So, most of you may think I require IBM statistics, SPSS statistics tool, or I require any of this advanced design expert tool, or I require any of this Python integrated tools for finding out the sum of squares, or sum of squares within the groups, or to find out the degrees of freedom. Okay, all these things I require advanced tools, some may think, but that is not required. So you can go to this data analysis. Here you can see ANOVA single factor. So before explaining or before taking up this ANOVA, I will just give an overview of what is ANOVA and what all we get and what we should look into during doing this ANOVA single factor or ANOVA two factor without replication or with replication. That I am going to explain in this. So ANOVA single factor. Okay, what does this give, or what you get interpretation of the results through this ANOVA single factor, that I am going to explain. Then I will show you what and all we get using this ANOVA single factor. Okay, so Basically, whenever I'm telling about the ANOVA single factor analysis, it will analyze the variance among the experimental results in your statistical analysis. So, what it will give is the number of observations which what we have, and through that it will give very important known as F value, P value, and sum of squares. So, what is this sum of squares means? We have these three trials. You can clearly see. Admin, is this visible? Is this Excel screen visible?
Yes, sir. Yes, sir.
Ah,
It's visible, sir. Please go ahead.
okay. Okay. Thank you very much. Now I have three trials. Okay. So what does the sum of square means? This shows how much the group means differ from one another. So here, among this, I got 68.9 as one of the average. For this, I got 71.1. For this, I got 66.5. For this, I got 71.4. For this, I got 73.5. Like this, I have got different values. So among these, how each of this sum of squares, okay, varies means how the group mean varies among each of these set of experimental trials. Whether UTS, that is, UTS means here ultimate tensile strength. In mechanical, it may be ultimate tensile strength. For computer science researchers, it may be different. It may be some other output which you are getting for the input which you have given to the system. Or, for example, for electronic researchers, E&C researchers, it may be like antenna angle you have varied, or you have varied the microwave frequency. For that, my variation in the microwave frequency, or for the variation in the antenna angle, what is the signal strength that you are receiving? Okay, that may be your uh, output. Okay, so for me, this ultimate tensor strength was the output. So it will help us know how much variation is there within the group, within the set of values which I have taken, and whether this experimental data which I have considered, it is statistically validated or it is statistically strong, and whether the hypothesis which I have built, that the ultimate tensile strength increases with the moringa fiber, it is right or wrong. That interpretation I will be able to make with this ANOVA. So you can see input range. It will ask for input range. So what I will do, I will take this set of input range. I will choose, that is, select the input range. Okay. So I will go to, yes, here. Now, clearly I got what is the sum, average, variance, and what is the F value and P value for each of these five different set of input factors which I have given here. Okay, what does this values represent here, and what does the critical inference it is giving, that we have to understand here. Okay, so here I have given the set of values from the experimental results I have chosen here, and I am asking the ANOVA what is whether the F value and P value are satisfying the experimental outcomes. So that is what I am doing using the Excel sheet here. So what the summary table is giving in this is, so each group has 9 observations. Here, count 9 means each group is having 9 observations. So sum means sum of all the 9 observations. Here, sum of all these 9 observations. Okay, so that is sum. Okay, average of all the 9 observations, variance. So this is for all the experimental readings, and then it is giving the F value and P value. So it is telling that how much whether this test statistically satisfies, or whether this statistically it is irrelevant. It will give you that interpretation. Here, F value is 208.1597, which is very much greater than the significant difference between the group values, which will tell that, okay, that is the variance between the tested factors is high and it has having a strong effect on the results. So, what is having strong effect on the results means the variation in the moringa fiber weight percentage is having a strong effect on the results. So that is what this F value is specifying. There are two things we should know: F value and F critical value and P value. So it is telling us that from the ANOVA analysis, the F critical value is very negligibly small and F value is greater, which tells that the moringa fiber is having greater impact on the results. So thereby you can clearly carry about the experimentation by varying these moringa fibers and testing for the value. So whatever data set you have got, it is statistically validated, and you will be able to predict the value statistically also. That is what it is giving. Okay, that is what it is telling, that the values which you have obtained are perfect and you can go ahead with the statistical validation. So, how this is helpful means you are writing a research paper. Now you have got some experimental findings. Now they will ask whatever experiment you have done as per design of experiments, and whether you have carried out any statistical validation, and whether the statistical validation of the experimental results are well within the prescribed limit. So what it will help us is, it will help us provide this validation using the experimental data, and thereby we can rely on the experimental results which we have got, and it will give us validation that the results which we are obtained, especially through the set of experiments, will be will hold good, and we are going to predict further. Say we have done for 10, 20, 30, using this descriptive statistics and the regression equation, we can predict further for different set of values, different set of percentage of the moringa fiber. So that way we can predict the values, and we can validate our experimental findings, and we can develop the research paper. So further, this Excel will help us in other things as well. This especially when we are understanding about basic aspects related to experimental trials. What it will do is, it will help understand about the variation in the output results with reference to input factors, and it will help us plot number of graphs. Okay, based on this you can plot multiple graphs using your options. Okay, you can do scatter plots, you can do uh, line charts, you can do the bar charts. Okay, you can change the values, you can go to this, you can change the values, and you can rely upon the results obtained from this Excel, and you can change here, you can go to, you can change the trend lines. Here you can go to the chart styles, and you can change what type of the chart element you want, and also if you want this to be a chart filters, you can change the names of these values, as well as if you want this to be a further different chart, you can go here. Okay, you can change series chart type. I can change this to bar chart. Here I can get the bar chart from this, or column chart from this. I can change it, I can get the column chart. Okay, so you can get the column chart for different observations which are obtained here, and you can get the error bar as well. Add error bars. You can add the error bars to this standard error, standard deviation. This is what I was referring to, standard deviation. Okay, you can add the error bars as a result of standard deviation. Okay, so because most of the research now they ask about error bars, so you can add the error bars as part of the standard deviations, and you can get the trend lines. Okay, so all these things we can do using the Excel sheet, and further, one important thing that is very you have very important thing in this is descriptive statistics. Okay, what is this descriptive statistics means? When you go further and further in the experimental tool, yeah, very important what is known as validating the result and finding the alternate equations or for building equations or mathematical formulations for the experiments which you have carried out. So in that, for that, descriptive statistics plays a very important role. So what it will do is it will help you understand, especially uh, to know about what is the frequency, what is the mean value, what is the minimum and maximum values, what is the average, what is the variability in the data. All these things it will help you understand. So I will just give the input range. Okay, I will run the descriptive statistics. It will ask, please choose at least one summary statistics. Click OK. Save. I am getting complete set of values. So what it is telling, the average of column 1 is 68.544, average of column 2 is 67, average of column 3, standard error, median values, range, what is the maximum and minimum range, and what is the sum, and what is the skewness. Okay, skewness and kurtosis, sometimes when you are doing a lot of experiments, like you are running more than you are having, say, sometimes stress strain diagram you will be doing. In stress strain diagram, you will be having more than, say, around 1000 to 1200 data points. In that, during that time, it is very difficult to know about all these aspects. So during that time, skewness of the results plays a very important. So what is the skewness of the results means? It will basically help us understand about how the readings which we are getting, especially with reference to the input values, it is skewing away from the predictions, or it is moving away from the predicted values. So that is what it will give. Means it measures the asymmetry, means how much it is distorting from the given data set, or it is moving towards left or right of the median line. So that will help you understand whether the experimental readings are following the average path, or it is getting skewed to the right or left. That will be understood through this descriptive statistics. Okay, so and one more very important thing is generally histogram. Okay, histogram, what it will do is it will give you a thorough understanding of the central tendency of the values. So what is the central tendency of the values means? It will help you understand how you can show the frequency distribution of your data. Okay, means from 68 to 69 MPa, how many trials you got the values. From 60, that is from 69 to 70 MPa, how many trials you get the values. From 70 to 71 MPa, how many trials you get the values. 72 to 73 MPa, how much rank values you got. Like that, it will help you build the that is the data set for the given analysis. So like that, you can develop your own t-square test, z-square test, rank and percentile test, or simple correlation. You can do all these things here. Correlation, you can do the correlation, select the data here, build the correlation for this. You can either go rows or you can go to that is column wise, and you can select the values. Click OK. Input range. Should have a definition column. Yes, just a minute. We have to build a reference for this. So the reference value we should have whenever we are doing the correlation. That is, we should have the in what is the value which we are getting and what are the correlation values, especially to what we should correlate. Indigenous reference. Okay, so this one we have to have a reference value for correlating the two data sets. So like this, we can have the quite a lot of various data analysis which can be accomplished using this Excel file. So we can get the exponential smoothing, as well as we can have the Fourier analysis. We can have the moving average. We can find the rank and percentile, and we can have the various set of statistical values evolved from this experimental data which we are having. And also, very important thing is we can remove any of the errors or duplicate values which we are having. Suppose we are having a number of duplicate entries. Say, same experimental values again and again you have entered, or suppose you are having multiple data entries. So you can go to this remove duplicates. You can do it, and you can delete the for this merge cell should be removed. You can remove duplicate values, and you can highlight whenever you are doing data validation. You can highlight the values, and also any of this conditional formatting, like highlight the cell rules. If I want any value greater than or equal to, suppose I select this complete set of values, format cells that are equal to, say 10. Click OK. You can select this format cells, conditional formatting equal to, you can see whichever rows that are equal to 10. Okay, the weight percentage of glass fiber is equal to 10. It will highlight that condition, and it will give you the output. In that way, you can do quite a lot of data analytics using the Excel, and you can compute the skewness histogram, and you can check the normality shape, and you can also interpret the distribution. All these things is possible with your Excel sheet itself. And additionally, if you have this kutos, there is one very important tool you can see here, kutos and kutos plus. If you have this, you can further format your data, and you can run quite a lot of experimental trials in this. You can see here there is a lot of you can insert your own function or your own mathematical relation, and you can test for that, and you can run the data analysis on this two Excel sheets. So in this way, it will help you in quite a lot of aspects, particularly to find out the average of the experimental results, variance of the experimental results, standard deviation, and to validate the trial data, and also to find out the analysis of variance, that is ANOVA, and also to do the regression analysis. For everything this will help you. And this, using this simple Excel tool only, you can write a generalized paper with some basic statistical validation. So in that way you can get your papers also through. And also you can develop on this. You can develop some basic mathematical formulations or correlations, and develop mathematical equations based on the different weight percentages of these input factors, or different residuals in the input factor, and you can try to understand how these experimental results are being validated with the statistical outcomes. So in that way, we can carry about quite a lot of experimental validations. And also you can plot a number of comparative graphs as well. You can develop like this. You can do the Taguchi analysis as well. So you can see in one of this, the basic Taguchi, it is carried out mean effect plots and all. You can carry out the basic Taguchi in this using the Excel itself. You can find out responses for means, and you can identify which is better, and you can plot the values. Okay, you can get the optimality RSM, that is response surface based optimality, done through the basic Excel file itself. And also you can say multiple comparison if you want to do multiple comparison, like if you want to get the, yes, uh, if you want to do for different compositions, say if you want to do a different multiple comparison with reference to time, or with reference to immersion time for any of the water absorption content, you can carry out the experimental, that is, you can plot the graph and identify at what extent of the time you are going to see the change or saturation. You can see here, you can put a trend line here. Uh, you can put a trend line. You can change this trend line. You can change it to linear forecast, or more options you can go. If I want logarithmic, logarithmic, if you have negative values, it is not possible. But if you have just positive values, it is okay. You can see a trend lines. Yes, more option. I can go to this option, trend line. Yes, M20 based on the series. In this, I can get for different polynomial. If you want, you can get the polynomial. Here, if we want equation for this, display equation on the chart, display R square value on the chart. There, I can get equation for this. That is, water absorption is varying as a function of immersion time, like y is equal to minus 6 e power minus is minus 6 e power minus 6 into x square plus 0.0048 into x plus 0.6253. If I want to predict for above 300, like 305 hours or 310 hours or 315 hours or 320 hours, if I just substitute here 3 5 hour, 305 or 310, 320, I can get the value, or I can get the prediction. Okay, so you can see the prediction line. You can change it. I can make it moving average also. Okay, so you can see moving average period. You can change from 2 to, you can make more refined. You can
Excuse me,
change the,
sir.
yes, madam.
Hello, sir. Sir, timing is timing is more.
The order of the polynomial, and I can make the my curve fitting very smooth or finer to the input values. Here, I can make this curve fitting very close to the input values, but my polynomial will vary. See, I will I'll just go to this, add the trend line, add the trend line, go to more options. I will go to this polynomial. Say if I do 2-degree polynomial, second order polynomial, I will not get a smooth curve. If I go to sixth order polynomial, you can clearly see I will get display equation, display R value, set intercept. Okay, so I can clearly make out that this readings which I am getting, it will be close to the predicted values. Okay, so if I use this equation and predict the values, my experimental value will be close to the actual value. So in this way, even multiple data, you can do the smoothing also. Okay, smoothing of the curves that can also be carried out, because only origin or other things we may think that smoothing of the series data series is possible only using the origin or MATLAB, but in Excel also we can do the exponential curve fitting or smoothing of the values. All those things we can carry out with our simple Excel data also. So in that way, we can get multiple of the outputs or multiple readings. We can plot it using the different tests and different graphing options in the Excel sheet. So all these things are possible using the data analytics. So as there is a limitation of time, we will try to continue. If given an option, we can do all these things. We can do hands-on session where I will share you Excel value previous before only, and we will try to do 3D plots also. So here like this, we have here time, temperature, storage modulus. We can also go for the 3D three-dimensional plots, surface plots as well. We can plot it. All these things it is possible using the Excel sheet. So in the coming sessions, we can go with surface plots, contour plots. Here we are having time, we are having temperature and storage modulus. So time, temperature, storage modulus. Here it will come x-axis, y-axis, z-axis. So we can do this 3D surface plots, 3D contour plots using the Excel itself, because contour plots and all we generally do using the MATLAB software, or we generally do using the Python software. But in Excel only it is possible to do 3D plots. So all these things we'll try to understand, and we have add-ins also. If you want, you can add in multiples of this custom toolbars, and we can do the data analysis, as well as we can do the plotting functions using the Excel sheet. So in the coming classes, we will try to understand about all those things also. So thank you for providing this opportunity, madam. So if any questions, audience, you
Yeah.
can feel free
Any
to ask.
questions from audience, please? Social science, especially in the stream, sir.
Okay, okay, madam.
Sir, I requesting you to, sir. We want another session from your side, sir.
Okay, okay, definitely, madam. We will learn about
Yes,
different
sir.
charts, like we have the radar chart, 3D surface charts, all these things we can. Hello.
Transforming research and decision making in mechanical engineering today.
Very good question, madam. Especially
Hmm.
whenever we are doing quite a lot of experimental work, madam, we cannot do, because we will do for say 9 set of values or say 27 set of values, because we cannot do it for quite a large, huge number of data sets. That time, what we will do is we will do pilot experiments and we will interpolate these values through predictive statistics, or through this Excel sheet. We'll get the regression equations. Through that, we are going to interpolate for number of values, and we will take one experiment. Say I have done for 10, 20, 30. In this, I have done for uh, 10, 20, 30 percentage. Suppose I want it for 40, 50 percentage. Through the regression equation, I can get the values for 40, 50, and then I need not test for all that up to 40, 50, 60. I will do it for one pilot. 40% I will take, that's it. I will check whether experimental value for 40% I got 75 MPa. If I get this through the statistical equation, if I get 72 MPa, the difference will be 71 MPa minus 70 MPa. So one so different, our equation which we have obtained is correct. So in that way, I can interpolate the values for multiple set of data also, and I can avoid doing very huge experiments, because in mechanical one experiment itself will cost quite a lot of things. Because in this ultimate tensile strength, for one sample itself, it is costing more than 300 to 500 rupees. So for the young researchers, if they want to carry about say around 27 or 81 specimen test, it is highly impossible, because 81 specimens into 500 rupees means it will go more than 40, 50,000. Instead of that 81, any nine they can do, they can develop a regression equation, and any one as a pilot they can take, which they have not tested. Like I have tested for 10, 20, 30. Other than that, any like 27.5. I can do experiment for 27.5, and I can find the value using statistics also, statistical equation also for 27.5. If both are matching, then that equation I can apply and interpolate for.
Hello.
Yes, madam. Is it
Yeah, sir.
audible, madam?
Yeah, audible, sir. Thank you, sir, for your information and expertise with us today. I also thank all the participants for their active presence and engagement, which made this session meaningful and successful. My special thanks to the organizing team of International House of Education for their efforts in making this webinar possible. Thank you, one and all. I request all the audience to switch on your camera. We'll take one group photo. Audience, please switch on your cameras. Okay, sir. Thank you.
Thank you very much, madam.
Thank you,
Thank you
sir,
for
for in
providing.
detail information, mean, standard deviation, regression, basic analysis for ANOVA, F value, satisfaction level. Thank you so much for giving a informative session, sir.
Thank you very much, madam. Thank you very
Thank
much for
thank you.
providing this opportunity, madam.
Yeah, sir. Thank you so much, sir.